Linked list, and we are going to write the code in Java. We have installed the IntelliJ, and from the IntelliJ we can actually write the code. So I created a project called linked list. So let's get started. So what's a linked list? This is the basic that we are actually covering over here. So what's a linked list? Linked list is a structure something like this, right? So we are talking essentially we are talking about a single linked list. We're not going to circular linked list, double linked list, and stuff like that. So let's say it's a structure something like this, where we can actually have, let's say, some values 5, -1, 2, 3, and stuff like that, and the last value is actually null. So this kind of data structure is called a linked list. It's a single linked list. So in the single linked list, you actually have a head, and then what you have is you actually have every node has data, and it has a pointer to the next node. My handwriting is super horrible, so don't worry about it, but like so this is a pointer, and there's a pointer to the next node. So in this case, in your first case, 5 is basically the data, and then 5 actually points to -1, which is the new next node, right? So for creating a linked list, what we need to do is we need to actually create a class for the node, and we actually need to create a class for the linked list, and that linked list will basically just have a head over there, right? So that is basically what we are going to do. Right now I've taken integers, but it can be any different value, right? So we'll be actually using a template for that, right? So what we'll do is we'll just start writing code. So we'll go to Java class, and we'll say this is a node class, right? I'll add this, and I'll check in the code too. So in the node class, basically we'll create it templatized, right? So it's a templatized node class, and what we do is we actually have a public. I'll just make everything public right now to make things easy, and we actually have public t data and public node t, which is next, right? So these are the two variables of this, and then what we'll have is we'll actually have the constructor. So we'll say public node, and it will get a t data, and then we'll say this dot data is equal to data. That's it. I think that will actually that will take care of our that will take care of the code for our what do you call the node. Next, what I want to do is I want to actually create the class for the linked list. So we'll actually create a class for the linked list. So I'll right click over here, new Java class, and we'll actually say this is a linked list. Okay. Linked list, we'll also create this as a templatized one, and then this linked list will basically have a head. So we'll say public public node t, which is actually head, right? We'll just keep the constructor. So we'll say linked list. We'll do nothing over here. We'll just say head is equal to null. That's all we are doing, right? So that's basically what your linked list is, right? Let's say write some functions for adding the node to the head, adding the node to the tail. So that will basically be one or two more functions. So we'll just write one or two more functions over here. So adding the node to the head. So let's see how that works. So let's say if there is no node. So there's nothing in this linked list. At that point, head was actually pointing to null, and let's say I want to add something to the head. What I will do is, if the linked list was null, what we'll do is, let's say I added 5, so my head, which was pointing to null, will start pointing to 5, and 5 is already pointing to null, right? So that becomes the head. So that'll be one case. And after that, let's say if there are some nodes over there. So in our case, it was like 5, -1, 4, and let's say 3. So in this case, if there were already values, and let's say I want to add 6 to it, so I'll create a new node 6, check if the head is null. If the head is actually not null, then what we'll do is we'll point 6 to 5. Head, which was pointing over here to 5, what we'll do is instead of 5, it'll start pointing to 6. So head actually points to 6. So now this becomes your new head, right? So that is basically your adding the node to the head. Adding the node to the tail, what we will do is we'll do the same thing we'll actually figure out if the node is actually pointing to if there's nothing which is there in the head, then what we'll do is whatever is the new node, we actually say that that is the head. Otherwise, what we'll do is we'll actually take a template, a temp node. So we'll take a temp node and then we'll point it to the head. We'll keep moving this temp node till the very end when it is at 3. So when it is at 3 and the next is actually null, the temp node will actually reach over here. At that point, let's say I want to add 7. So what I will do is 7 was pointing to null. I will say temp.next, instead of pointing to this, it starts pointing to 7 and 7 points to null. That's basically the entire logic for it. Let's write the code for this. These are pretty simple code. So we'll say public void, and I'll say public void add node to head or something like that, right? And we'll say t data. So this is the node that I want to add. Maybe I should say append. Append is actually adding to the end. Actually prepend. Yeah, we'll just keep it append. Okay, so first thing we'll check is if head is equal to null. If head is equal to null, so in that case, what we are going to do is we are going to actually, even before that, we should create a node. So we'll say node t node is equal to new node with data, right? So we create a new node. We'll check if head is equal to null. If head is equal to null, what we'll say is we'll say head is equal to the new node that we actually created, and we just return. That's basically what we'll do. Otherwise, what we'll do is we'll say node.next will be equal to head, and then head is equal to node, right? That's basically what the code is. If I want to say add it to the tail, there can actually be a better option if we actually have a tail node also over here. So we can actually add it to the tail. That will actually be better in terms of complexity. So complexity will be O of 1 in that time, but we'll say we'll not do that right now. So we'll say append to tail or something, right? So we create a node, new node. That is what it is. If head is null, we just say that head is equal to node and we return. Otherwise, what we do is we create a temp node. So we'll say node t temp is equal to head. So we create a new node. We don't create a node, we just create a pointer which points to the head. Then we'll say while temp temp.next is not equal to null. While temp.next is not equal to null, what we'll do is we'll say temp is equal to temp.next. Temp is equal to temp.next, and we just keep moving. And then after that, like when we break out of this loop, at that point temp.next is pointing to null. So we'll say temp.next will be equal to the new node that we actually just created over here, line number 19. So that should actually take care of this, right? Let's actually create a linked list and we'll actually do some things. So we'll say linked list of integer list is equal to new linked list. Okay, and then we'll say list dot append, and let's say we say 5. So we added 5 to the head of the node, right? We'll say list dot append to tail, and we'll say -1, right? So -1, and we'll just break. We'll just put a breakpoint over here just to see how this works. So we'll come over here, we'll add a new configuration, and this is an application, and we'll find the main class. So this is the main class. We'll say okay, and this is edit. Yeah, sure, doesn't matter. Okay, so we run this. Oh, not run this. We actually debug this. So we debug this, and we reach over here. So we actually have a list which has a head heads data is 5, heads dot next is -1, and that points to null. That is basically what our code is. We'll write some more functions in this, but this is just the basics.